Share screen. Are you able to see my screen?
Yes, we can.
Thanks. So this was one of the publications that I shared, Building for a Circular Future, which was originally published in 2016, and it was revised in 2018. And it was published by actually one firm in the context of a particular project that they were involved in, especially to compare the value in reuse, transforming a building and reusing its elements as opposed to building completely with new materials. And so if you scan through these buildings, you'll find very interesting, some of the observations that these people got. They actually, the firm is it is a Dutch practicing firm that have specialized a lot on circular economy, the Exen Architects. I'm sure our student architects in the house may have not heard such people. They only know of the main, like in Frank Gehry's and the Zara Deeds. But there are quite a very number of architect people doing very interesting jobs. So if you look at some of these materials, you'll find very interesting findings, very interesting solutions that the people are already using, and case studies of projects. So like this, you'll find a number of projects that this particular office have worked on, different sites, employing different strategies. And they summarize about 5 circular business models that are applicable within the construction industry as well. First, they're looking at the circular supply chain. Okay. And we talked about a little bit about circular supply chain. So the question of the circular supply chain, what we really want to understand, how, if you look at a supply chain would be probably for a particular product, let's say, or particular material. So let's say, for example, steel as a construction material. If you look at its supply chain, then we will be looking at the steel through the entire value chain, right from the production of the steel to the end use of it and demolition. So that would include the steel mills, it would include the those who are handling the logistics, it could include the hardwares, those who are involved in the distributions or resale, to the fabricators, up to the building, and the point of dismantling. So within this supply chain, a lot of waste is generated, as already we have discussed, and there are quite a number of business solutions that are being reported, business models that are developing within the supply chain. So some people are only focusing on the extraction part of the supply chain. Some may focus only on the manufacturing part of the supply chain, such that you're looking at the industrial processes, how to reduce waste within the production unit in the factory, how to encourage reuse, how to encourage more energy efficient systems, and water recycling, things like that. More basically in the industrial production processes. There are those that have also gone to target more the logistics, how to reduce wastage along the supply chain, probably by aggregating orders, some focusing more on modularity. So like you got to design buildings, elements precisely by order, so that only the material that you have designed for is delivered, that you need is delivered on site. And if you could look at some in Kenya, some of the companies that are venturing into, for example, the roofing trusses, like in steel, steel structures, Of course, even Mabati rolling mills, though Mabati rolling mills are, they're dealing with light gauge steel. You find now they would be able to, they have internal technical team and they have softwares that if you send them as architects or engineers, the drawings, they would ask you structural engineers who are doing the roof trusses. You send them the drawings, then they would be able to feed it into their system and be able to precisely get you the elements that you require for your truss so that you're not necessarily over ordering, and they could cut for you materials into pieces. So now like Mabati, you could get as long as 10 meters of Mabati if you want that particular span for a production. So those are certain people who have already focused on that particular supply chain to reduce the wastages within that particular element of supply chain at the design level. You could come to the construction site, those who now collect what has been, probably still you did your precise calculation, but even when you do the precise calculation, I think the QSS in the house can confirm to us that normally when you are estimating, and this is sometimes some things that architects don't bother about, or engineers, we don't engage with the quantity surveyors, that when they are making their estimates for materials, whether on the consultant side, but more specifically on the contractor side, when they're placing the orders, there are normally factors that are assumed to cover the issues of losses, the issues of damages, and those factors could be, it's a range. So you may find for some materials they provided even 10% wastages. I want to ask one of our QSs, what, for example, tiles, when you're working estimations for tiles, what percentages do you give as a provision for wastage? Any of the two QSs in the house, could you just give us an indication of the factors you normally use?
When it comes to tiling, the provision we place usually accounts for the cutting. So the waste would be allocated, let's say, between 10 and 30%.
Right, between 10 and 30%. Well, generally, if you were to summarize for all materials, what would be the range? Would it still be within that 10 to 30%, or some could be far less, or some could even be higher?
Some could be far less. I haven't encountered any materials that have gone past 30%.
Right.
Yeah.
Yeah, thank you for that feedback. And that is very interesting, because you would be shocked that, I don't know, wonder the architects colleagues in the room and all the engineers and other colleagues who are also involved within the building. Is that a new discovery? Did you ever think that our friends, though very professional, we provide as much as 30% allowance for waste, and that is bought? It is by design, because it is designed such that when the orders are made and they've already assumed 10 to 30%, imagine a scenario where 25% has been assumed because of, to cover just for, breakages or, the cutting or that point, the wastage. What is your impression? Any architect or engineer or anyone in the group? What would you do if you have never thought about it, but if you now know that when estimates are being prepared, whether on the consultant side or on the contractor side, that our colleagues make such assumptions, what would you do differently with that knowledge as an architect or as an engineer, project engineer? Whether you are studying architecture or not, or just assume if you are an architect or an engineer, what would you do differently with that knowledge? Or even as a QS who now is aware of the impact of this material, what would you do differently? What would you engage your colleagues on? What would you discuss with your fellow consultants to do differently so that you deal with that particular amount? Think about 10 to 30%. If you are handling a project of which has material cost of, say, 10 million. So just imagine that 1 million or up between 1 to 3 million shillings will be wasted, just for a 10 million value of projects. That is a very significant amount of money, even from financial perspective, leave alone, the resources perspective, the material, the energy, the water, all that. What would you do differently to be able, and in most cases, our clients come to us that we really want to save cost. So what normally we eventually do, you begin compromising on the quality of materials. So we order cheap quality materials. Sometimes we want to even compromise on the spaces. So you provide a tiny, even though in the schools, some of you know, like a basic standard bedroom is 3x3, you begin doing very tiny spaces that do not even meet the anthropometrics and ergonomics that you learned in school, because you want to really lower the cost to meet the client's tight budget. While on one side you're having, 1 million already 3 million. If you were to reduce, for example, from the 3 million to 1.5, you would already give the client a better quality of space. But most of us are not aware. So just my question then is, what would you do different? One comment as so that we move on. It's a free sharing. I don't need to really mention names.
Okay, as much as I'm not an architect or an engineer, if we take the example of roofing,
Connected.
Generally, the more detailed the design, the less assumptions as a quantity surveyor I have to make. And in that regard, the less I have to allocate extra expenditure for wastage and or unused materials on site. So I guess the more detailed design helps in that regard.
Okay, so you would then prefer that at what level? Because the details are often provided, but when do you need them? Sometimes what you're saying is, for most offices, actually, because of the labor manpower challenge, they provide the details much later after even tendering has happened, that the production drawings with those clean, many details. For our colleagues who may not be technical, just to understand when the QS colleague is saying details are not there. You have the drawings that normally, if you look, for example, your residential house, you'll find a plan that shows you where your rooms are, how people can connect with the rooms. You'll have a very nice 3D design showing you how the model of the house looks like. But then that is not enough to say so much about what is actually going to be built. Because if you look at that floor, it would be made, probably they've just said tiles. It would be made of tile. If you look at the window, the rough designs, schematic designs, we call them technically, would be showing you just the sizes, their positions, you can see them on form. But there's a lot of information on that particular window. How high is it? What material is it made of? Which steel? What sizes of those steels are? How does it open? The glasses that are going to be fitted into it, what kind of glass, how thick, So those are some of the intricate details that are very critical to be able to inform the cost of the building. So what the QS is saying, that if the details were provided early enough, when they are working out the estimates and shed materials, then it is possible to reduce the waste, because then you are not making assumptions. Okay, so that's one way. I saw Prudence raised her hand. Prudence, your hand was up. Prudence, your hand was up. All right, I'm assuming it is accidents. So the other
no, okay. What I was saying is, I'm sorry for the delay. I was saying that is a key aspect of project management, as we know, and definitely we can reduce from 10 to 30% is just by ensuring that proper workmanship is done. Raymond is saying that we should really control it from the design stage, but also during the construction stage, the workmanship by maybe the steel fixers should be people who are well trained on job. You should also include quality management on site. Yeah.
Right. Prudence is saying yes, also looking at the labor applying, more stringent management approaches on the project. I absolutely agree, because of course, also what QS said also makes sense. You need the details, which is one element, so that he doesn't make provisional sums, but he can precisely measure every element and know that this space, this wall will have this element, this opening is this size, is particular, and then measure it and cost it. But then what Prudence is also adding is, yes, even if you do that precisely, there are other assumptions that could be made to factor in wastages, especially during handling, during actual construction work. So breakages and all that. Even the fundi, some of them may be able, an architect has provided a very nice pattern, even semicircular. So that's what things really need to be cut. And one thing I like, I normally observe a lot when we are in school, especially, we like creativity without thinking so much, sometimes the implications. Very nice curvilinear forms, spaces that are very intricate, but what if those spaces are going to be done by a foodie who just has, a very basic tile cutting machine? So for him to cut, to be able to achieve that corner, he may have to waste so many tiles that are broken and thrown away for him to achieve the curve. The same, even if it is a curved molding of a wall, though they have to do a lot of timber work to be able to achieve that curve. That is different if the same curve you gave to somebody who had a better machinery that have a curve cutter that is able to easily cut that surface. It would be different if you had a contractor that has even a very nice mold that would be able to, he doesn't need to do a lot of, support. He doesn't need a much timber. I don't want to use the technical term, I don't want to use much of the technical terms, the formwork, scaffolding, but for the sake of our colleagues, that you don't need a lot of mold or supporting materials to achieve that wall. So that is the other aspect of it, that to reduce also that waste, they need to provide more allowance at that stage, is that you also need highly competent teams that are quite connected with the designers. Before, we didn't have to have a lot of that waste because most of us, the designers, by then, of course, I didn't live then, you find that they were hands-on. People like Le Corbusier, for those who are in school, if you look at Frank Gehry, like the Guggenheim Museum, Gehry, those people who are the pioneers of concrete, they knew the material so much that they are designing the space and they have interacted with the material. They know what it can achieve, they know what cannot happen, they know what spaces are difficult to achieve, they know in the industry even what is the height of a particular board, and these are what is also not the height. So that their connection between the craftsmen and the professionals who are designing, the consultants, was so close. So then you don't have a lot of wastage because of the labor limitations. That is not as much the case in our current practice. I dare say that some of us may leave school having not even interacted with certain elements of fabrication. If I may ask some of our colleagues, I was so shocked sometimes you would be dealing, yes, MDF particle boards can be used for partitioning. But if I was to ask you today, you ask an architect, maybe the quantity surveying colleagues may know some of their hearts, the length of the material available, but you find that some of architects or even the engineers, they don't know. So for example, if you don't know what is the length of the MDF boards in the market, are they 2.7, 2.1, 2.4, 2.6? So if you knew that height, you see, when you are designing, even your partitioning and how the frames that are holding the MDF boards are, you would be able to reduce on wastages because, for example, if you knew that the MDFs come in sizes of 2.1, 2.4, then you wouldn't decide to provide a space, a height that requires you that you cut one board into a piece which is going to be, maybe let me make it simpler with the tiles. I find the tiles are very interesting. We know tiles come in what sizes? 300 by 300 millimeters, 330 by 330, 400 by 400. So let me take a case that as an architect, I designed a room space that if I was to take 3 meters, for example, if you designed the floor space dimensions to be in the multiple, say, of 3.3, 330, or multiples of 300, or multiples of 400, or multiples of 600, which are the standard sizes of the tiles in the market. What would that mean? It would mean that even when now the contract is being awarded, because the QS, of course, will be measuring the tiles in square meter, is not dealing with the box, but the contractor and the foodies who are building, they will not just be talking of square meters, then they will be moving from square meters to the actual pieces of tile. So when they buy the tiles and they're installing, if you had provided that same room, say, for example, a multiples of 3.3 would be 9.9 meters, for example. So a 9.9 meters room by 6.6 could result in less wastage if the client preferred to use a tile of 3.3 compared to somebody who would have done a room of 9.5 meters by 6.2 meters. Because for him to achieve the space, really fill that space with tile, it would mean that there is a particular portion of tile that will be cut and would be left as a half, left over and unutilized. So those are some of the intricate design that if we know at what particular stage there, which you're talking about here at the design, you will still be able to help realize. So you could probably, as a business model, just decide that you are going to deal with that particular issue of information challenge. And that is why some of our colleagues here who are technical would probably, the leverages we could use would be things like BIM, to be more, don't look at building information, modeling as just a question of aesthetics but to begin to understand materials, more elements, have a bit closer interface with our fundi and have a greater conversation between the consultants earlier on in the design stage, so that when you are making the decisions, you are making them together. If the architect draws a line to represent a wall or to represent a certain element, he begins to think of that line has an implication on material, it has an implication on labor, it has certain implementation also on timelines and so. And the colleagues who are involved with those elements can interrogate them, and you agree and look at all considered evaluation. And that is why we are also designing this challenge, that you are working as a team and you must work from the onset. Not that let the architect who is in the team design and finish, then the QS now come do the cost estimation. No, we want you, all of us, to conceptualize this process together. And that technically we call it integrated design, where all the issues, all team members are working together as a team to develop a holistic solution. Then, of course, we talked about other models we can look at. Recovery and recycling. These I think we already talked about, recover materials and recycling. And we need to differentiate recycling from reuse. Recycling mostly deals with a bit of, it is low energy, if you remember the ladder we talked about. So recycling for me, on this particular exercise, yes, we can use more recycled products. For example, if you find paving blocks that have been recycled, or even roofing tiles. So for example, we have companies currently who are providing plastic roofing tiles that are made from recycled plastics. Those would be good. But I want us more to encourage the solutions that are higher in the middle and the upper part of the R ladder that we shared yesterday. Product life extension, that is exactly what I'm saying, encouraging reuse of materials, so that we are dealing with the purpose materials when they're still in their, or more original form, where they can retain the same functionalities that they had initially. And we talked of sharing and the likes. Now, allow me at this point just to share with us a certain video. Then we can discuss this video after over an example of a project. I'm going to share two videos. I'm going to play two videos. One is a video of a thesis project of a student thinking about circular economy of architecture. The other one I'm going to share an example of a project done by Arup engineers. I think some of you may have already heard of Arup. It's a very well-established multidisciplinary firm. Sorry, that started before I could share the screen, so just give me a moment. Are you able to see my screen? Are you able to see the video?
Yes, we can see it.
Okay, let us watch. Sorry. This is not the one I want to show now. Sorry. Just a bit. I sincerely apologize for that confusion. Okay, that is it.
As a company, we've started looking at the circular economy about 2 years ago, and it's really interesting what that concept could mean. As an industry, we really face quite a few challenges. The construction industry produces a lot of waste, and we need to rethink what that means really for the sustainability and the future of our industry, and thinking about waste and materials in a different way and finding circular ways to use things like steel, wood, and other construction materials, I think is really, really critical. In particular, in the context of some of the big trends that we're facing, urbanization, climate change, resource shortages, they all put pressure on our industry to really innovate and find new ways to deliver the spaces and places and infrastructure that we will need in the future. It's much more about collaboration, finding ways to work together, finding common ways to create value out of materials and spaces. So the circular economy is really about rethinking how the entire industry works along the supply chain.
At the beginning, we wanted to build something that would respond to the waste crisis in London through construction and through domestic use. At the same time, we had lots of conversations with colleagues about the circular economy, and we put those two things together and thought, what would it mean if we built a building in accordance with the principles of the circular economy? So we took lots of components from all of the suppliers in the construction industry, put them together to make this building, the idea being that we would then be able to take them apart and give them all back to the suppliers. We've collaborated with BAM, with construction firms to put this together, and now we're learning about how we put these things back into the supply chain, and I think that's going to be an ongoing conversation. We've had so much interest in this. We've had a fantastic collaboration with lots of people, but in particular Frenner and Reifer have really helped us by putting this together for us, and they're going to take it apart, and they've really joined in the process with us.
In terms of structure, we began quite quickly in focusing on particular materials. And steel was one material we were very interested in because the steel industry has been thinking quite hard about circular economy, partly because steel is not seen as a sustainable material. And what we wanted was a structure that could be deconstructed and reused, not just downcycled. And we worked quite hard with ArcelorMittal in terms of detailing and availability of material to make sure that this was truly circular. We spoke with ArcelorMittal about whether they could supply the steel, and one of the things we did with the building was we worked to what they could get for us and what was available, and therefore we weren't using new steel, and we actually adjusted the size of the building slightly to deal with that. We also talked to them about best forms of connections that then could make the steel very reusable afterwards. including things such as the connections to cladding, not making holes in the steelwork, leaving them as kind of unmarked as possible.
My role as structural engineer on this circular building was to develop lots of ideas. Firstly, for the structural frame. So we developed a steel concept, which was then clad in a very unique facade panelization idea, where we've used push fit connections and then clamps called limb adapters to connect them to the steel frame. This has all come together as layering the building, which has actually kind of developed a circular idea of being able to deconstruct the building.
My role within the circular economy building was these panels, the panels that form the whole building. So basically we started with a pitched roof house, and we decided to go through a very simple detailing of the wiki panels. Having the panels cut precisely, following a computational process, you eliminate all the possible waste that you can get on site. So that's very important, very key for this whole ideology. And once they're brought to site, just to bring them up, it's a very straightforward process. So again, it cuts the time, becomes more efficient, and it's, I guess, almost like foolproof, because it becomes a kit and it gives you more flexibility in terms of what you want to do. And it's just finding the rationale behind how you put a building together.
I was involved in the whole process on site, starting from the first day setting up the site and all the way through to the end. And it was really interesting to see the construction detailing forming into reality on site. It's very easy to revert back to common practice, to take the easy way out. But we made a conscious decision at every process when we had a problem that we encountered to try to resolve it as much as we could in a circular way, so that we were being true to the ethos of the project and making sure that whatever we put in, we were able to take back out again.
Firstly, to discuss the insulation, we really toyed with the different types of insulation. Rockwool, we know, is a good, sustainable insulation types, but it does lead us to set thicknesses of wool. We actually approached Procter Group, who make an aerogel blanket. Actually, they came back with this recycled version of the aerogel blanket, which uses all the waste products they've been collecting for years. So it performs not as well as their kind of standard aerogel blanket, but it does perform better than the likes of Rockwool. The other kind of key aspect for buildings, other than the insulation, is the water tightness. So actually, we found Fatro, who have a membrane which is mechanically fixed, so therefore it does allow us to disassemble it. The other thing which is really interesting about it is that they have their own recycling plant, so they can take old membrane and they can turn it back into new membrane.
A key aspect of the circular economy is that when materials are taken out of a building at its end of life, they can then be reused. But in order to reuse those materials and incorporate them in new designs, you need to know a few bits of key information about them. So things as simple as just the size and weight of the components, but also their design information, the specifications that they were made to, these kinds of things. Each of the materials in the building is tagged with a QR code. You can access that information when you're inside the building through the bespoke website, which sets up sort of the reasons why we engaged in this in the first place, and then digs down into the levels of detail on the structure, on the skin, and the other parts of the building, and then further to another level of detail on specific components and materials that we have used, which would hopefully allow maintenance and replacement of those materials through the life of the building easier, but also at the end of life, allow those materials to be made available to other buildings and other designs.
Designing systems for the circular building was quite challenging because especially services, they come in lots of components. Manufacturers could potentially take the onus of designing systems which are circular. And this is one of the strategies that we took. For instance, the battery system is water-based. And I think it's the only cradle-to-cradle certified battery system in the world. We wanted to have energy storage in the building because it ties with the idea of decentralized energy storage that can actually smoothen out the peaks peaks in the electricity network. There are other strategies that we took on board in the prototype to add more circularity. And usually when we kind of hit a barrier, we try to be creative about it. So with the lighting, for instance, the fixings are all magnetic, so that lighting can be easily removed. It can have also onboard electronics to provide controls, so minimizing actually the amount of little boxes that you have to distribute in order to achieve a more granular control.
My responsibility for the prototype was to design the ventilation system. For this prototype, we have designed and built a 3D printed and laser cut mechanical ventilation system with heat recovery. This unit provides fresh air to the indoor space, allowing for a better environment while reducing the energy consumption. All the internal components have been 3D printed by using 90% PET recycled filament, and all the software and hardware are open source. This was a good opportunity for us to test those digital manufacturing technologies within the building services.
Throughout the process of looking at the interior aspects of the circular building, we were surprised to find that there are actually companies out there that are addressing the way we approach interior fit out in a circular way. So looking at using recycled material content, but not only that, but the way we use it in a fit out so that it can be reused after that. One of the most interesting things I found through the project is the take back scheme. So companies are really instigating relationships within our supply chain, and it encourages suppliers to have a vested interest to take back material and use it again and again.
I think one of the most rewarding aspects is actually to build the physical prototype and see people interact with it and let them smell and touch and feel how something like the idea of the circular economy can actually, in a very simple way, turn into a really pleasant building and environment. It's incredibly valuable that we build things like this to show people that it is a possible future. I think one of the most important things we learned is that the idea of the circular economy forces you to collaborate much earlier in the design process, both with our colleagues and also with our clients and the design chain to produce something that's tangible.
When we began the exercise here, we, as designers, expect a certain degree of challenge and a certain process that we would normally go through. This building, interestingly, has challenged us in different ways. We asked questions of ourselves, we asked questions of the supply chain, the primary one being, can we build a building within the framework of the circular economy philosophies? And this in itself would have been a first for, I think, the industry, and certainly first for our team. Mostly the answer to that was positive. We did have certain wobbles along the way, and as you would expect, our design process morphed along the way. The building began in a certain shape and a certain volume. As we learned more about what was available to us and what the market could do for us, we needed to adapt and flex. And this, for us, created certain challenges in a very non-linear process. The primary difference being that we needed to be more mentally agile. We needed to say to ourselves, well, we can't actually find a circular product, so we needed to go out and search and explore, and that in itself then changed what we then believed to be standard detailing that we were going to utilize. So it's been a huge learning experience.
Okay. How did you like that video? Before I show the other short one, yeah, takeaways from that. What are reactions? Any reactions on that video? Who wants to go first? Yes, Shikuku, just go ahead. Go ahead. If you want to talk, just talk. Yes, let's start with.
So, first things first. As a team, they have come together and put in their efforts. I know we are lacking at that, but we'll work on it. Second thing, they have mainly focused on reusability. So it's not on changing value necessarily, because Steel you can reuse as long as you maintain it, and the timber panels that they've made, they can reuse, and even the insulation, they can also reuse the wool insulation. So they focused majorly on reuse. So if you ask me honestly, I was thinking more on either decomposition or change in use. So that was a nice incentive to push me towards that direction. And then finally, I didn't take note of the furniture, but it seemed like they said the furniture was also from recyclable materials. I believe that's what they said. So it's not only on the scale of putting up the building, but also the fittings, or more like the furniture in the building. So it's an inspiring project. As much as it's not touched on, the only thing is a lot of times I wonder, despite our target of reusability, human beings have evolved so much to be, you see, like in cities, to go multiple floors. How feasible is each of these construction technologies? Can we find a way to be able to catch up to the current ways of the modern or the urban setting? Because doing 3 floors, 2 floors, that's with the technology, it's easy. So just my mind always goes to trying to see if you can revolutionize, not only for a low-level building, but also for high rises. So thank you for sharing.
Yeah, thanks a lot for those reactions, Chikuku. You asked a poster, just a wonder there. We'll respond to it a little bit. Somebody else before I just comment on the particular issue with the skyscrapers. Yeah, somebody else was talking. You can go ahead. No one? Really?
Hello.
Yes, Nixon, go
Hello.
ahead.
So I think the project, though on a small scale, but it really shows the important tenets of reducing waste. First of all, I think the level of involvement, multidisciplinary, of which each and everyone contributes to ensuring that waste is reduced. Then secondly, I think also in terms of, one of the members in the conversation also mentioned that in terms of controlling detail, because you can see that they thought into detail of how they wanted things even to be assembled and all that, and that reduces wastage. Now, in terms of, say, urbanization and high rises, I believe just from that video, then we can also think about standardization of design. I know as architects, most of the time we always think about aesthetics and spatial relationships, but also if we standardize designs in such a way that it is not too complicated to produce these materials, or to know, like what you mentioned, for example, say sizes of rooms, sizes of materials and all that. When we standardize and use that in, use those standard measurements or standard sizes in design, then it reduces waste by a greater percentage. So that's mainly it from the video. Thank you.
Yeah, thank you, Nixon, for the comments. Anyone? Interesting, you're talking about standardization. It's a very interesting topic because it has, on one side, it is an enabler of circularity in the construction sector, but also on another side, it is also a barrier. So we have to look at it in both senses. In what time would it be a barrier? In which case would it be an enabler? And of course, when we are thinking also of Nyonyesha Hub, look at a scenario that we are going to build a number of them. So the more we are able to establish the systems, you design connections, you design materials, and that could be applied at scale, that's a good thing. But also we don't need to be really just take it as a blanket that it is a solution for all circumstances and then we just apply standardization, because then some of the challenges we are dealing with now are because of the issues of too much standardization, where there was no need of being, we have just need to be flexible and consider the context and at least bit deviate and apply our creativity and thinking to respond to that particular context we are dealing with. So yeah, that's a very good observation. And also, of course, tying in with the comments that your colleague has said. Maybe, unless somebody wants to comment briefly, I want to play the next video, which is not real. This is it's at a conceptual level, because this is a student fellow. Look at them is like your colleague, and I know some of you will be thinking about also your project. You're working with thesis. What can you do in academically, and what could you investigate? So you might probably find ideas for topics, but the issues that he brings, they are very real and practical, and you could realize that actually you could apply it at a scale. Partly he responds to some of the issues that who asked the previous question? Just forgotten the name. Anyway, he raised concern about building at city level, multiple floors, basically skyscrapers. How can we be able to apply that? And it is very possible. I actually would tell you, before I even play the video, on that component, to embrace circularity actually makes it easier even to build the skyscrapers. Because some of the techniques like those people at Arup were showing, the things that they were considering, if you had a chance to read the materials that I've provided, I'll just scan through some of them. Design for deconstruction or disassembly is one of the key strategies or principles for us to promote circular economy. Why design for disassembly or disconstruction? They are talking about, we want to encourage recovery of material so that you are able to remove the elements of the building, the components, in a way that you least deteriorate their value, so that you can use them again in another project without having to go so much through reprocessing them or repurposing them or refurbishing them. So this design for disassembly includes certain elements like, the kind of joints that you are applying. So you could see there, like they were looking at how they jointed the steel. And some of you have civil structural engineers in the groups. You could see them working with bolts for certain joints, but then on the main bodies where the walling would be, where the materials will be receiving a facade, another layer on top, they were not doing the holes. So that the whole idea is that if you're going to laminate a certain material, if you're going to add material on it, you want it to be easily dismantled or getting out. We're talking about, again, lamination. Right now, even timber, we are promoting, laminates, materials that will have composites materials. The more you have highly processed industrialized composite materials with many layers, the lower the possibilities of reusing them. Because for you to dismantle them so that you are able to extract some of the materials and safely use them in more or less their existing form becomes very difficult. So you want to begin thinking about those kinds of fittings, how you bring the components together, the fixtures, where we begin to think about encouraging more bolting, nuts, use of nuts, bolts, rather than welding parts. You begin to look at, free seamless joints. What some of the videos you're going to upload by later on the channel that you'll be able to watch takes, for example, an inspiration from the Lego. I know many of you are familiar. When we were children, probably some of you played with toys and you're familiar with Legos. And this interlocking, that the toys, you can build blocks by just interlocking them. And if you look at those blocks, you're often able to some of them form very strong joints that you cannot really shake that particular block, whatever you have created laterally, or you may not be able to apply tensile forces that make it a fast. Of course, when you're looking at the design, you would be looking at all those forces that are coming, the tensile, the compressive forces, the shear forces. So how can you use certain kind of those things like joints? Because if you provided, for example, just the joints by interlocking, and you are particularly only subjecting that element of the building to, say, tensile force. Now, it means that if you need to disassemble it, you will need to dismantle the building and recover those materials to reuse. You will not need to come up, break all the entire component down or demolish the entire building. You will need only to simply apply the other force, which that particular structure will not be able to sustain, and easily you recover it almost the way it was placed, and then you can just add a little bit of value of it and go use it somewhere. Those are some things that were coming out clearly from that presentation. They also talked about, of course, when they were looking at the interiors, the finishes, they're looking at what, of course, materials are made from. You're looking at thinking of insulation. They're talking about a little bit of bio-based or natural materials, and we'll talk about this again further tomorrow. And when we're talking about healthy materials, and we will touch a little bit on that. They also were looking at lighting systems, talked about take-back schemes. So they were talking about, remember what I said yesterday with regards to Philip's case, that other example of the project where you begin to look at products as services. So rather than you buying, bulbs, lighting fittings, that you're getting into service contracts with the manufacturers to supply you with that particular building service, rather than selling to you the product so that you own the entire materials, and at the end of it, you just dump them. But it's now their responsibility to provide you the service. If their equipment is able to provide lighting for you effectively for 2 years, once the 2 years have elapsed, they come back, they take back their fittings, they give you other fittings that are able to continue providing you with the light. Because they have very established processes for manufacturing, they subject back the ones that they took to improve on them, so that they continue in the circulation. So they talk there a bit about take-back scheme. Another interesting conversation that I also could pick from that video was to deal with the concept of material passports. You remember me mentioning material passports yesterday. And you saw the guy there talking about them introducing this idea of using data, that as they were looking at all the materials, they were recording information, taking inventory of what material that is, what is it made of, and what are the quantities, the sizes, the volumes, potentially if they know the source, who are the suppliers, and then that material, all that information is encrypted into a particular, code with a unique number that you could be able to access with a barcode, so that if you scan, later on that building element has been installed, but when you are coming to check on it, if you go scan that code, you can be able to tell, yeah, this was this type of wood, it was this weight, it was from this manufacturer or this source. And so that gives you opportunities to be able to decide, as at that point, what would be the best way to reuse that particular material, to recycling, whatever the purpose, what function you want to do. So they're bringing this element, that idea that the building, you look at the building as a material bank, that it is actually a storage of a couple of materials that have unique identities. And colleagues, if we may expand that conversation a little bit, we are living in the digital age. Of course, this is a digital revolution. And even looking at the financial sector, the financial sector has been really going further ahead of our construction industry. People are talking of blockchain technology. So now with blockchain technology and the big data, it is very possible for you to look at even that Nonyesha Hub, almost every element, how much materials by who, which source, as much as intricate, complex the supply chain is, that you have tiles that have come from India, you may have this steel that have come from nails that have come from a different supplier. It is now very much possible for us to be able to deliver a building product that we can tell, just by a click of a button, we can be able to search in less than 30 minutes, you can be able to rip apart that building and know that all these are the components of what went in and these are their qualities. If you leverage on one side the building information modeling, that we have software as cards now that allow us that you can tell really zoom at a very micro level, look at the floor to the ingrains and details at that level and feed in that materials, and that can be extracted and transferred and stored into data that can be used later. So that we can also make reuse easier. That, like, unlike the exercise we are going to do next week, if you go beat timber or any broken furniture with some steel, you have no idea to tell what type of steel is this, yeah? Where was it sourced from? When was it actually manufactured? And you know, sometimes if you know the issues even of when, for example, you know this is a steel that was manufactured in 1970, if you go back, you may be able to begin looking at the standards. You know, by then they were producing steel, this steel of this category to this standard, say to this BS standard. And if your structural engineering colleague even want to analyze that, tell you, this structural standard, this particular steel, then you would be able to assess and analyze. But right now, if we were to put this element to be, say, the roof truss member, particularly the struts that is to bear this particular load, then it may not bear this load, because here we need a steel that has been produced to this quality, because this quality of steel has these particular characteristics that make it strong. So you are able to make very informed decisions because of the data that is ingrained in that material. But as we are now, would be a lot of guesswork. We have a lot of guesswork because the data is negligible. And to that extent, that is why, as we are going to be building together, we would be testing now that we don't have the reference data to refer to. We just have to think about it, make assumptions, and if we can do some small scale tests where critical and practical, at least we engage on those tests so that we affirm our assumptions, so that at the end of the day, the hubs that we will have designed, the projects we're delivering, we can be able to assure the users that they are of highest quality in terms of performance, but also they are also of highest performance in terms of their environmental attributes, because they involve materials that have been recycled, that have higher recycled content, but reused materials. So those are some of the things that I could pick from that particular presentation. Of course, not all, but just a bit of it. So allow me quickly, Jen, just to share this briefly. Then I can see it's already 5. You may excuse me to extend again a little bit. Then we can move towards wrapping up. So I'm going to share my screen. Allow me first to switch on that video. Okay, yeah, it is.
Both and I.
So come here, share screen. There we go. Okay.
Hi, I'm David Nee.
Are you able to see my screen now? Okay,
Yes,
can you see my screen?
We can.
Okay. Okay, then let's proceed.
I'll start my thesis presentations with the topics of the circular economy of architecture, followed by the proposal of meta-rig. Meta means the metabolic change in social environment that influence the architecture. Rig means vessel, material component that used to form the space. So what I emphasize here is an independent life cycle of the material that is divided from the building life cycle. Building life cycle begins the moment construction starts, where material life cycle starts long before we extract from the earth. But often, building and material are perceived as one. Because of that, when the building hits the end cycle, so does the material, and eventually both end up in the landfill. That is just one example of the linear economy system. Packaging turned into waste after product is consumed because no one holds the responsibility to own it. And built environment alone has contributed a tremendous amount of waste, because often we tend to change new packaging when the product is not satisfied. In this case, the product is our space. The linear system has existed for centuries, but was ignored until the waste and carbon emission has become a noticeable threat to the environment. And that is where a new mindset hits in, the circular economy. A different way to approach earth resources through rethink a system of package design that can be reused over time. Unlike recycle, it is designed to be repaired easily and redistributed without involving high energy to process the recycled waste. The final goal is simple, to remove disposal phase from the supply and demand chain. So that opens up a new possibility to think how circular economy can influence architecture. Often without building are eternal, so it is designed that way. But many didn't realize that building has a lifespan too. End cycle of a building isn't always because of the structural failure, but also because of the paradigm shift of demands due to the changes in social environments. The building that was built on the same year might not result in the same value, but the value is justified by the need, and sometimes it is just because the content is less favorable to the demand of its area. And all it needs is to move on and find the demand that adores it. But how can a building find its value if it is tied to the ground? So that inspired the idea of breaking building into smaller parts through component-based design. Small enough to be relocated easily according to demands. Then invest on a small component will be more worthy because the value is maintained with a constant demand chain compared to a solid building that might degrade over time. The building, however, is non-existent without material, so it is just land or the material bank for the investor to park their properties to generate profit, and everything will operate as a form of rental because at the end of the day, users just need the space, but not to own material. Gradually, this practice could generate a network of supply chain through small component trading, and that brings up another challenge, compatibilities. The first design of Lego brick molded in 1949 still fits fine with any new Lego brick design today. It is made possible because of the consistency in grids and rules behind the interlocking systems. So we adopt this idea into the component design of the building through a three-dimensional recursion rule to set a common scale and size to all components with a compatible joint. So the column can be used as beam, floor as wall, or the window as railing. Additional attachment can also be equipped on certain component to enhance their strength for looks. So that component will have more than one function to increase the chance for demands. And the beauty of it is the efficiency of mass production of a single design, a single jointing, but for many purposes. And we bring this concept into the design of an office, the small office, flexible office. We combine the typology of the co-working with the conventional office block for the small-scale pioneers that are collaboration-based, so they are more receptive to the idea of space sharing. You can choose between making your office public or private, or you can have both, all within a single set of recursion grids. The site is located in an urban setting of Medini, facing to the lake and adjacent to the commercial lots. The intention is to maximize public space and interaction, so we divide the movement between pedestrian and vehicle into two zones. The circular office and warehouse will be located adjacent to the access road, so it functions like a custom checkpoint for the material before they assemble on site. Then we connect the site to the surrounding to enhance its exposure physically and visually, and adding more value to the urban oasis by bringing out all the service area to the first floor to create a seamless connection from one end to the other end on the ground. The form are defined through the hierarchy of scale that seemingly ascends from the lake and allowing more views from every towers to the north. A single unit is adequate for a micro enterprise and can stack up to a maximum of 8 units to the size of a medium enterprise. The expansion can either be done separately or they can negotiate with the adjacent unit if it is occupied. If the agreement is accepted, unit swapping can be done in just 2 days over the weekend. However, each enterprise can only expand up to 2 units on a single level to maintain the diversity and welfare of each party. So in order to achieve rapid relocation of 2 offices in 2 days, every components are designed to be assembled and disassembled easily. The time frame will be determined by the workforce and installation time of each component. Since the nature of the building is designed to change constantly, supportive mechanism will also be part of building utility to ease the work. Each unit will be granted a maximum of 6 grids to be expanded, Installation will start from inner parts to the facades, so to avoid damage to the component during installation. Heavier components such as structural grid or hollow slab will be assisted by taking that mounts on the upper structural frame. Every component designed will be mechanically joined instead of chemically, so dismantle and relocation process will be made easier when the demand shifts, without causing damage to the material, therefore no disposal. Smaller component will have a simpler connection that can be assembled by the user when it is just a minor alteration. Circuit system is also designed into a series of modules that can be connected in the form of grids to simplify and shorten the wiring work too. And in total, it will take approximately 8 hours to complete the installation, with 3 wall floors and the conversion of 520 to the largest of 775 square feet. Office swapping involves 2 units. That means everything will be duplicated, including the disassemble process. But if we divide the task into 2 days within a week, the work schedule of each day will roll back to 8 hours. From the look of it, you will notice the boundary of offices because the expansion are interlocked in all directions. But what we can notice is a social culture of working environment that is different throughout the impression of unit layout. Some are more substance, where the other are more receptive. So the architecture impression could also somehow represent the company image to attract opportunity and collaboration with like-minded party. But that results in the complexity of variations. So a component database will be developed to record the quantity of components installed on each unit. This database could also integrate with software for the user to test and visualize the layout on the screen before they send the order to the management warehouse. Units with the same owner will have the option to link to Office through a set of personal staircase module small enough to fit into a unit upon installation. As for the service systems, riser will channel directly into the unit from the outmost layer of the building rather than the horizontal distribution from the inside, so to maximize the flexibility for future changes. Layout of service systems are also rearranged to have as minimal contact as possible to every floor. The riser will be designed in the form of module as well, so that it can be disassembled during the extraction of structural component on the event of building shrinking in future. In other words, it could also be the event of structural maintenance in case we have new upgrades in the future too. And after, the life cycle of the material will have more defined purpose that only cross path with the building life cycle. So when the building cycle ends, it will continue its journey with limitless possibility, not only to modern buildings, but also applicable to conservations, adaptive use, or rapid transformation for demands during the pandemic outbreak. And the best of all, the more often a material is reused, the more embodied energy it could recover every time it completes a cycle. And suddenly, material will be so valuable that everyone wants to take good care for its reusability. And to that point, people will no longer associate property to just area or volume, but also preservation of earth resources that are limited and valuable.
Right. Good. Comments? Let's hear reactions on that. Who wants to go first? Hello. Elizabeth. Elizabeth Kimani. Let's hear ladies' comments this time. Hello, can you hear me? Can anyone who can hear me say hi?
Hi.
Hi. Kumbe, I'm audible. Thank you. Any comments? Starting with one of our ladies. Okay, it seems our sisters don't have a comment. The brothers. Shikuku, you were wondering whether there are possibilities for having building multi-family, multi-storied buildings, applying the circular economy concept. What is your impression from that fellow student proposal? Hi, Shikuku, I can't hear you.
Hello. Hi.
Yes, hi. Go ahead.
There we go. Okay.
Hello. Hi, Shikuku.
Seems to be a problem with my.
Okay, there's a problem with your microphone. Okay, anyone else? So with an issue in the internet. Anyone with a comment? What impressed you even about the presentation? If you leave alone the content.
Okay, I had a bit of a mixed reaction to the proposal. In that, it's a good idea having something that is actually movable and having something that you can alter to suit your needs is a very convenient and futuristic idea. But then now, the part where I had an issue with it is because I'm trying to think about something timeless, right? Let's say like the piece that was done by Frank Lloyd, Falling Waters. Now I'm trying to think, what if someone decided to make Falling Waters movable? Does it mean that when it's moved, that it will be placed somewhere else and it will be placed the same way? Or does it mean because I can be able to move it, it won't have one specific form? So in terms of now the designer's identity, or in terms of the designer's vision, you won't be able to have something that is timeless. You won't say that this is how this building was originally designed. But now when it comes to circular economy and the utilization of materials and functionality, it's actually pretty functional. But at the same time, as a designer, you want something that is there and something that you can be identified with even after you're not around anymore. But I think it will be a very practical idea.
Interesting, very interesting observation. Anyone wants to comment on Joachim's concern or any other things before I just comment as we wrap on that?
I feel like if the original design was outstanding, no matter where it is moved, it will be named as this originally came from so-and-so's design of this time at this place, in which case you will still live on through it, but the materials will be capable to be used somewhere else where they are needed, if at all at that point where it was used originally, it wasn't anymore needed.
Okay, very interesting observation. Sorry, Joachim,
just a minute.
Yeah.
Yes, just a minute. You see, the thing is, if I can reply to Valerie, when you're designing as a designer, you design something based on context. So if I design on this site, I'm designing based on the climatic factors or the site factors of this particular site. So when it's moved somewhere else, it will be designed, or it will be reassembled to suit the conditions of the site it will be moved to. So I don't believe that it can maintain originality when it's movable, if that makes sense. And at the end of the day, where the designer was intending to have the original is the context already boosts the design itself. So I don't think it will still maintain that original flair.
Okay. Yeah, good point. Thinking now as a designer, I would wade into that issue. If I may just comment, yeah. First, let me comment first on the presentation, why I actually showed you that presentation. First, because this is a student proposal just sharing their concept about circular economy and vision. Of course, he tried first, of course, by laying the context, the issue and the challenge, and then he presents his proposal. And in terms of also the format of the presentation, I wanted us to also look at it when you will be working on your submissions. You know, there would be the thinking first, consolidating where you are coming from. For his case, he's only talking about circular economy. And so looking at the built environment in the context of the dwindling resources, the climate change agenda, and the need for us to embrace sustainability. In our case, we are talking about that, but on top of that, we're also talking about our contextual social issues. Here we are dealing with the inclusion challenges. We are dealing with even our construction sector facing very unique challenges in terms of the labor. We are partly, of course, a country that is in between high tech, but also we have a lot of readily available manual human labor that could be utilized. We're in the middle of a lot of imported and also locally manufactured and processed construction materials that we could utilize, whether new or secondhand. But also we have an abundance of natural materials that could also be used with the labor. So we have a mix of many things, whichever, of course, direction you choose as your philosophy and approach. Remember the 6 Ps we were talking about yesterday. And different groups will take different approaches. That's what is happened with every designer. And Joachim is right, that as a designer, of course, you have your aspiration, you have your identity for that design, true. But whatever we choose, these cases are not necessarily for us to copy paste, but they are just to provoke us inspiration. They are trying to solve a problem for their context. Even the Arup proposal, that is based in London. You know, London, the European context is completely different for ours, but the principles are certainly the same. If you're thinking of the building to be dismantled, you're thinking of modularity, how would it apply in our context? So that would be my concern, Joachim, that yes, what the concerns that you have, there is a tension here as a designer that is conceptualizing this space to be circular, to be designed for flexibility for future use. How do you still achieve flexibility, achieve adaptability, achieve resilience while maintaining identity, yeah? While maintaining that your original intended purpose and the context. So I would reframe that question this way. How do you design for a changing context? And truth be told, Joachim and the rest of us who may be worried similarly, gone are the days we used to think that we would design our buildings or products and they live as a legacy, uninterrupted in their context, not touched in perpetuity. That is never the case where we are dealing. Even those historical architectural artifacts, they are undergoing conservation because with time, of course, they deteriorate in terms of physical conditions. So then they need to be preserved. And there's a lot of conversation and even argument. I was watching last week, a huge debate about a particular monument conservation. To what extent do you bring in new elements? and to what extent do you conserve? I think it was a question about, there was a discussion about the Pantheon, and many of you know about the very famous, you know, we're talking about Gothic, Greek architecture. Those are very, very serious artifacts, but how do you restore those pillars while preserving the original context? Those are very challenging debate. But if I may simplify it, also not to be technical for our colleagues. Look, yes, the environmental context, even now we know, is not static because we are having climate change. You may have made your assumptions, even in terms of water levels. How would this building still be able to adapt itself to 20 years where it was designed thinking there will be no issue with flood, and suddenly there was high water level rises? So even if you don't move it to another site, we are now living in a scenario that we may not be 100% confident that the building would be facing the same climatic condition the next 50 years as it is facing when we are designing and building it now. So knowing that, then, how do we design to keep our identity, to keep the intention while anticipating the change then? Another thing, economics changes are also happening. Look at our cities around us in campuses. Some of you are staying in institutions where the universities sprang up so suddenly and guys have begun changing their houses. You go to Nairobi, for those who are within the CBDs, if you look at Juja, for example, those who are in JKUAT, Juja of 15 years ago is different from Juja of now. So you're beginning to deal with issues of urban gentrification, you know, decaying neighborhoods that need to be repurposed. Even planning, zoning regulations have to keep being changed because we are growing and developing pretty fast. So you're looking at parklands that were mansionettes and designed as mansionettes. You walk to some places in Kilimani that were mansionettes that people were living in have been converted into offices. So we have things called dweller transformation, that users are changing their faces so fast to an extent that sometimes the reality in school, you think the design will not be touched. But I tell you, from your initial concept, even in the architectural office practice, by the time you come with the first proposal you did, and by the time you get to the tendering and the contract is awarded, there is a little bit of up and kidogo changes you're beginning to tweak, because now you're dealing with, you know, the dynamics of politics of the client, you're dealing with the issues of the budget. And by the time you're getting on to site and you're still pushing, you will of course achieve probably 99% of your original intent, but you find 1% has been negotiated to factor in the realities, just 1 year realities. So if we are alive to those factors of dweller transformations that there would be changing. Question is, how do we design to try anticipate them as much as possible? We are in such a context as designers, and you young generation coming into the practice, you can help us figure out this, because the old designers, the architects, the engineers, the social scientists, the environmentalists of those ages of 50 years ago, they were on a very stable system that things were not changing as fast. You could say, yeah, this would be. Me, when I was 5 years old, we knew it would rain by second week of March, first week of March. If it delayed at a particular date, if it delayed, it could be 1 or 2 days. And it will stop by a certain period of time. And now currently, I'm not that old, but just in my generation, we can hardly predict. In my garden, backyard garden, where I live, my wife planted some vegetables a month ago because it was really raining, and now they are blossoming. But suddenly, it is crazily hot within 2 weeks in the city. You can no longer predict these things. Fires in places that they were. If you looked at the news in December, Kentucky swept down a whole city and people, dying within those buildings. And when those buildings were being designed and constructed, those guys, the designers, then never anticipated that suddenly you would become having a storm without such a warning, that magnitude, and the buildings will be exposed to that. So they never bothered to really make the buildings that resilient for that spaces. But right here with us, colleagues, already what we are facing the scenarios that we have changing, things are changing rapidly. Concerns of security, that how do you balance now, even as a designer, the issues? On one hand, we want to create spaces that are accessible to all. Because of natural, we want to introduce natural lighting, views to the spaces and openness. But on the other side, we are worried about terrorism. Yeah, we want this space to be safe. On the other side, we are worried about the distance, being exposed to those who are having, COVID and similar pandemic. We don't know after COVID what would happen. Remember, people are saying the worst flu that we had was almost 100 years and since COVID came. But right now we have COVID. Before COVID, we had the swan, I think it was called H1N1, swine flu. We have many of these things that are really happening. So in that context, yes, how do we design for a changing context? How do we achieve modularity while still, you talk about modularity, yes, changing it also, there are still other concerns. Clients or as a user of our office space or as a building housing unit, you also want your unique identity, you want to identify with. So how do you manage those tensions? If I apply it finally as I conclude on that particular topic, think about we are designing Nyonyesha hubs in the universities, right? Right now we are constrained by, we will be provided by a site. For those who go to the University of Nairobi, currently the two sites options that we are being given. One is within a very contained space. When you get to site, you will see. The other one is slightly open. It is in between the spaces that are very prime. So maybe the university we would be designing for 50 users. But what if the university population is growing and the demand is increasing and then that facility needs to be expanded? Do we need to go build a complete new hub somewhere else? Or are we going to begin thinking of how are we able to build a sizable hub for the population that it can serve for now, but in the subsequent years we could add in, we could expand it while keeping its original identity and still being functional? What would be happening if even the way childcare is being handled, digital, whatever issues, that transformation that come into play? What if the university decides that, okay, we've built another new facility, maybe we're building an hospital or the university hospital or care place or new hostel where we are going to integrate the childcare facility center so that it means the hub that we had after 15 years or 10 years down the line, 5, they may want to put it into a different use, which is now not necessarily purely childcare. What would happen to the vision that you had, what we were really working with? Those are dynamics. So it is a tension. I would be very interested to see how we are taking these principles and we are interpreting them into solutions that would stand the test of time to be able to adjust to those dynamics in the future. That the purpose of all this conversation, and for us, this really, let me call it deduction or the training, was for us to raise these issues so that when we are designing, we are conscious about them and try to anticipate them and provide solutions. We will not be having a perfect answer, but we would have attempted to make a case, not theoretically this time only, like the way you guys are currently doing in school, but that we practically make it happen. So lastly, as I conclude on that particular conversation, and probably also on our session today, I liked the presentation that this thesis this gentleman made, and I want you to think about your presentation. Normally, as architects, engineers, we communicate with drawings, and we have very technical drawings for production targeted for client, contractors. We also have presentation drawings for the clients. But here, I want us to also think that over and above our contemporary presentation, we have a larger audience. That is, our client is the university, we have these mothers. We are going to go outside there to do crowdfunding for building these facilities. So we are going to present it to many people. So your final product, as much as it will be presented to judges who are pretty technical and can be able to synthesize the drawing, let us also think of how we can use communication medium that is appropriate. And I think part of that presentation begins to direct us there, because at the end of your presentation, after it is judged, we will be having public exhibition, as I said, that this will be live solutions that we will show there as typologies and possibilities. Just like for these guys, the case on YouTube. So think of how you will narrate your story, how you want to present them once you have concluded your all your design. And that means then that you need to begin documenting. Even as at right now, as you guys begin to work together, talk and brainstorming, you are going to the group, don't wait until now you begin to have proper design and get the technical drawing. The process is important as the final product. So that is just my final comment with regards to the session today. Because of time, I want to refer us to two particular documents. One of them that I shared is a very short document. I'm not going to run through it in details now, but you please make time to read through it because it elaborates these issues we were talking about. It is only 22 pages, designed for material recovery. They are highlighting, issues to deal with embodied energy. You will go back to recycling, practical issues to deal with disassembly. You will have issues to deal with adaptive reuse. Yeah, and then of course those will only take you about 7 pages. Then the remainder are just case studies, which you would choose whether you want to read through those case studies or not. But at least they would be able to help you appreciate the elements of those particular design strategies. And then they go to give also an exercise on how to do life cycle design. So I humbly request that you make time to read through that. I'm also going to upload this evening the tool that we are going to use for mapping materials and on site. I will defer us reading through it to the next time after the end of the remaining presentation. So tomorrow we convene at 9 a.m. Tomorrow we will have a little bit more time because we'll cover a lot more of the remaining contents. We'll cover a little bit on embodied carbon to deal with climate change and designing for climate resilience and climate mitigation. We will talk about healthy materials, and we'll touch a little bit on the design for justice, which of course I've already begun mentioning certain elements of it here. Then we will wrap up together with a roadmap for next week. What are we going to do next week? Practically, whether you are organizing the site visit by yourselves or you need help than the introductions. For those of you who are identifying sites like the EQUAT institutions or those who are working in institutions where their sites are already identified, how do we link you up? Well, so we would just cover a little bit of the logistics and then we wrap up the training session so that you guys can get into the proper work. So that is all from my end for today. I can take photo, screenshot before I take a comment and we break. I can see we were 22, now we are 17, 2 have left us. Unfortunately, I don't know who have left. As I said, we will provide certificate for attendance. And those who really have the contents, we would be certifying. So remember, we are working with universities, and this content has been covered nowhere in this country. We are the pioneers in circular construction, what we are trying to create here. So if you look at it in terms of expertise and your career, whether you're going to work with us post the competition and build a team of transformative construction, consultants and people who are driving the industry and builders, or you are going to run your practice, this content is very valuable if you would pay for it so highly. So I hope that you guys appreciate it and you take time. For those who have honored it and at least attended physically, yes, we are going to provide certificates to prove the attendance. And we will be looking at also certifying those who are reuse or green building or circular designers. What some of you may not be aware that though we are as humble as us, we are quite renowned expert in this space. Whether you're talking of green building or you're talking of circular economy. So it's quite a privilege to share and exchange with you and learn from each other. So just encourage your colleagues that take it lightly. That also, as like they take it lightly, we also will take them lightly. Much as you will win as a group, the practice and the life you live as an individual. So whatever we invest in is also the match that we receive. So thank you all those who have honored. Let us take a moment to take photo. Matano, are you there? We can take screenshot. We have two. I will of course request that we turn on our videos for the photos. Okay, here I come. In my next life, I want such a kofia ya Shikuku. Shikuku, si unitafutie moja mali hiyo ilikuwa imetoka.
Don't worry, it is here in this life, so we can always look for one.
I look forward. Immaculate, your photo looks like you are sleeping. That photo, could we just see your real face? Because it looks like you are so tired in this presentation. Hata tukiweka social media watu wata comment tu Elizabeth Kibani alikuwa ameboeka sana na hii presentation. Anyway, all right. Yeah, yes. Now we are talking. Eh? Okay, one more. Matano, have you taken the photos?
Let me do so right now.
Good. Great. Tell us when you are done so that we can. Yes. Oh, I took one without Elizabeth. Asna?
I have taken one.
Okay.
Or we can now change our poses so that I can take another one. Or you can smile.
Smile. Some of us only know how to laugh, not to smile.
We are good.
All right. So
a request.
Yep.
Nixon.
Yep.
A request, please. Could you share the links to the two videos?
Yes, we are uploading
to
them.
share with my people also to discuss on the site. That's okay. Okay.
Yeah. Matano will share the links once he finishes uploading them. Any comments or questions before we wrap? We quit for today. Raymond, unmute.
Yes.
Yes, go ahead. You were saying something.
No. I was saying not that I can think of.
Okay.
Yeah.
And Pauline? Pauline, do you have a word or you're just enjoying the sunlight? All right. Any comments? How would you like this? How would you prefer tomorrow's session to be delivered? If I may just ask, a mix of such intriguing, few videos here and there that we discuss, or just a lecture with slides like the way I did yesterday. Which one would you prefer?
Lectures are always boring, so we could do the fun side of things, of course.
An interactive one.
Oh, combination.
Good.
Sorry.
I really wish that you guys can also be interactive. Because sasa mimi nikiuliza maswali hata vile reaction wazee wamejikaza tu. You not like you would expect the usual suspects will talk, but the rest they just digest it and internet. Okay, tomorrow would be interactive. We will have a few clips here and there, discuss it in the context. No more boring lectures. So let us come tomorrow fully energized. Tell the colleagues we'll be having very nice interactive discussions. And let them come with the questions and ready to engage, not to listen to another boring lecture.
Just a reminder, tomorrow we'll also have air burgers.
Yeah, and we'll be recording those who attend tomorrow are the ones we'll provide the certificates of attendance.
Yeah.
So of course, with the exception, like the few names that I can remember attended, she, the one who gave apologies, called her. Anyway, yeah, the few that I can remember, if they miss tomorrow, at least those ones I can remember they were there. But none the rest, those who don't attend tomorrow, we wouldn't honor with our certificates of participation. Okay. Matano, do you have any announcements for us?
None, just to remind them to encourage their team members to also join in the sessions so that we are at par.
Great. And also follow us, tweet, we share the screenshots. Did we share the previous one? Yeah, so just comment on all these and engage and dispense the knowledge.
We'll also organize an award for the one who engages us mostly on social media as well.
Oh, wow. Okay, interesting.
Yes.
Sawa sawa. So guys, have a nice evening.